In this video, we're going to take a look at baking normals for both UE4 and Unity so that we get the best results. It really comes down to tangents and the tangent basis used to bake the normal map. Different software will use a different tangent basis to compute the normal. If you don't bake the normal map with the same tangent basis used to view the normal, then you will get shading errors. Substance Painter uses the MIC-T tangent basis, which is the same as UE4. Unity at this time uses a custom tangent basis. So for Unity, we will need to handle the export differently. So here in the viewport, you see the high-res mesh that we're going to bake from. And this is the low-res approximation of that. And so another thing that I want to mention about creating a good normal map is that you'll get the best results when the low-res mesh matches the high-res mesh as close as possible. So it becomes kind of a balancing act in creating a mesh that's low enough to be optimized. However, it has enough supporting edge loops and geometry to approximate the high-res version. So for example, here in this area, I'm just going to enable the high-res mesh, and I'm going to place this here into wireframe shaded mode. And let's go into face mode, and I'm just going to highlight this edge loop here. So notice in this case, I needed to add in this poly loop so that I could better support the curvature of this high-res mesh. So here we'll just jump back over to our shaded mode, and here this is a pretty extreme curved area. And so instead of having a single edge here, I actually created this poly loop, and I'll just enable this again so that we can see here this poly loop, and you can see that it's trying to approximate or more closely fit that high resolution mesh. Now, another area that you see here, I only have a single edge. So you can see that we have this single edge. However, let's go back into wireframe mode. We can see that the actual curvature of this high resolution mesh is way more extreme. So in this case, we don't have a very good match. However, with the smoothing group, we'll be able to get away with this. However, I would get an even better result if I were to have beveled this edge and again, just insert another poly loop to kind of fit this curvature of the high resolution, just as I did here in this bottom section. Okay, so let's just take a look at our mesh here. And so this is going to be the object that we work with. And again, I just want to point out that this mesh has just a single smoothing group. So all of the mesh normals are smoothed, and this is going to be the mesh that I export. Okay, so now we're going to export and bake our normal map for use in Unreal Engine 4. So here, I'm just going to export the selection, and I'm going to save this as part_SSG for single smoothing group, and we're going to use FBX. So here are the options that I use. Now, for the geometry, we want to make sure that smoothing groups is enabled. And for the tangents and binormals, we're going to make sure that we turn this off. As I mentioned earlier, Substance Painter is using MIC-T space, which is the same tangent basis that Unreal Engine 4 is using. Since we are using the same tangent basis to bake as well as view the normal map, this is considered to be a synced workflow. Because of that, I do not want to export the tangents and binormals in the FBX. I want to allow Substance Painter to compute them, and then I want to allow Unreal Engine 4 to compute them when I import the mesh. So in this case, we're going to leave this disabled. Now this is going to work because both Painter and UE4 are using MIC-T space, which means that they will calculate the tangents the same way. And then finally, I have Triangulate enabled. You want to make sure that you triangulate the mesh before you bake it. And you want to make sure that you utilize that exact same triangulated mesh in your engine, in our case, Unreal Engine 4, that was used to bake the normal map. So the two main settings we have, smoothing groups, triangulate, tangents and binormals off, and our mesh itself is using a single smoothing group. So now I can just export this, and we're going to jump over to Painter and actually bake the normal map. Let's first set up our project. So we'll go to File, New, and I need to select my mesh. So here we're going to make sure that we select this part_SSG. And I want to make sure that I utilize the normal map format for DirectX. And I need to make sure that I check compute tangent space per fragment. This is because we are going to be utilizing this normal map inside of UE4. For my document res, I'll just set it to 2K, and now we'll click OK. So here we have our mesh, and now we just need to bake the normal map. So here I'm going to activate my baked textures. And in this case for the common, let's set this to 2K and let's import the high-res mesh. So here is my high-res FBX. And I'm just going to enable the normal map. And here underneath my common settings, I'm just going to leave this at default and we're going to bake the texture. And so here we have our normal map. You can see that we get a very clean result. Here I'll come over to my textures tab and we'll take a look at this normal map. Here we have some fairly extreme gradients in the normal map. However, these areas are where the normal map needs to be correctly compensating for the smoothing of the low poly. Here back in Maya, you'll recall that we are just using a single smoothing group, and I'm doing that to create a more optimized version of my model, in the sense that, using smoothing groups can increase vertex count. We'll discuss that more in a bit. However, you can see that this single smoothing group is causing us to have some extreme shading areas here on the mesh. And so the gradients in the normal map are the compensation of that smoothing here on the low res model. Essentially, the normal map is doing its job, and we were able to bake a map that approximates our high-res version without having shading errors. So now let's jump over to Unreal Engine and take a look at the result. So here we are in UE4, and I want to talk about these FBX import options. Now, the main one that I want to focus on here is this normal input method. And because we are using the same tangent basis, and I did not export the tangents and binormals with the FBX, I want to choose this import normals method. This means it's going to import the normals from the FBX, but UE4 is going to compute the tangents and binormals. So here I'll just cancel this since I already have the mesh imported, and the normal map that was baked from Painter has been applied to the material, and so this is the result that we get. And as you can see, we have a very clean bake and we have no shading errors. And so with UE4 and Substance Painter, we have a synced tangent workflow. So now we're going to export our object for baking a normal map for use in Unity. So here I'm going to go to File, Export Selection, and here I'm just going to overwrite the file, so SSG single smoothing group. Again, we are just using a single smoothing group for this example. And this time I'm going to make sure that I have tangents and binormals enabled. Since at the recording of this video, Substance Painter only works with McT tangent space, I need to include the tangents in the FBX because they will be used to compute the normal map. So here we have smoothing groups, tangents and binormals, and then also we're going to make sure that we triangulate the mesh. As I covered earlier, we need to make sure that we triangulate the mesh before we bake it, and that same triangulated mesh that was used to bake the normal map is what we need to import into Unity. So now that we have all this together, I'll export this mesh and then we'll bake the map in Painter. So here we are in Painter. Let's go ahead and create a project, and let's go and find our mesh. So first we're going to utilize this single smoothing group mesh. And here, the normal map, we're going to be using OpenGL within Unity, and I need to make sure that my compute tangent space per frame fragment is disabled. So I need to make sure that this option is not enabled for use with Unity. Here, my document res, let's just set it at 2K. Everything is configured, we'll click OK. And here we have our mesh. So let's quickly just bake this normal map. So I will activate my bake textures. The common parameters, let's set this to 2K. Let's go and load in our high-res mesh. And here, we'll just disable all of these guys except for our normal. I'm going to leave all of these parameters here at default, and we will bake that normal map. So here, once again, I have my normal map baked. You can see that we have a clean result, no shading errors. Here on our textures tab, this is the normal map that was baked. So as I covered in the Unreal Engine section, you can see that our normal map has some extreme gradients. This is going to be due to the fact that we use just a single smoothing group, and these gradients are areas where the normal map needs to be correctly compensating for the smoothing of the low poly. And as we can see here, the normal map is doing its job, and we're getting a correct approximation of our high-res mesh. Here back in Maya, you'll recall that we are just using a single smoothing group, and I'm doing that to create a more optimized version of my model, in the sense that, using smoothing groups can increase vertex count. We'll discuss that more in a bit. However, you can see that this single smoothing group is causing us to have some extreme shading areas here on the mesh. And so the gradients in the normal map are the compensation of that smoothing here on the low res model. Essentially, the normal map is doing its job, and we were able to bake a map that approximates our high-res version without having shading errors. So now let's jump over to Unity and take a look at the result. And so here we are in Unity, and you can see that we are also getting a clean result here to our normal map. Here I have the mesh selected, and let's take a look at the import settings. Notice that for the normals and tangents, I have normal set to import and tangents set to import. Remember, we exported the tangents and binormals with the FBX. We use those to compute the normal map within Painter, and so in that case, in order for this to look correct, we need to make sure that we import those tangents from the FBX file. So to recap the process using MIKTSpace, in this scenario, we are using the same tangent basis, so we do not export tangents in the FBX file. Instead, we let Substance Painter, and in our case, Unreal Engine 4, calculate the tangents. This works because they are both using the same tangent space, which is MIKTSpace. Now, if we are not going to use MIKTSpace, in the case of what we showed with Unity, we do need to export tangents in the FBX. These are the tangents that are used to compute the normal map. In this case, Substance Painter will utilize the tangents found in the FBX. When you import the FBX into Unity, you then need to make sure that you also import the tangents from the FBX. This will also keep things in sync in the sense that you're utilizing the same tangents that are embedded in the FBX file itself. So on this mesh, we have been discussing utilizing a single smoothing group. And so here you can see this single smoothing group is actually producing a lot of shading errors here on our mesh. The reason is that we have this single group and it's just smoothing across all of the mesh normals. Now, we don't see this when we actually apply our normal map, and that is because the normal map is compensating for this high degree of smoothing. And thus we get rid of a lot of these errors once the normal map is applied. However, you can get into situations where utilizing a single smoothing group can cause these shading errors to reappear. And that's going to happen if you have a discrepancy in the tangents. Let's jump over to Unity and look at an example of this. So here we are inside of Unity, and you can start to see that we have some of these errors here. So if we just kind of look, here is one that's very clear. If we start to look over on this side, we can start to see some shading areas here and here as well. And so what's happened is I've taken this object, it has a single smoothing group, however, I just made it to where there was a discrepancy within the tangent basis. In this case, I baked with MIKT, however, Unity does not support that tangent basis, so in this case, we start to see these errors. Now, as you saw in the Unity section, a way to fix this is to make sure that we export the tangents in the FBX file, let Painter bake with those tangents, and then when we import this mesh back into Unity, we import those tangents in as well. That keeps everything in sync. So if you're using a single smoothing group and the tangents do not sync up, you're going to find errors like this here on your mesh. And you may have run into this before. So there's some different ways that we can control the shading on our object. Let's jump back over to Maya and take a look. So we can actually control the shading here on our object by adding in some supporting edge loops. Here in this case, I have an example of that where I had added this poly loop here, and so we can see that with that poly loop we start to get more of a uniform shading here between the angles of these two faces. Another demonstration of that, let's just come in here and add an edge loop, and so I'll just place one here and here. And so let's go back into object mode, and you can see that just by adding in that supporting edge loop, I start to get more of a uniform shading here. Now, another way that we can work with this is by creating multiple smoothing groups. So let's come over to this section here, and I'm just going to grab this row of edges, and I'm just going to delete my history first here, and I'm just going to go to my mesh display and just harden this edge. And so here, when I harden this edge, we'll go into object mode, you can see that here I've just put a smoothing split, and so I'm controlling the shading here as well. And so by adding multiple smoothing groups, we can control the shading and isolate it to specific areas of the mesh. As you can see, by adding supporting edge loops, we're actually adding some complexity to the object, so we're increasing the resolution of the geometry. And in a way, with smoothing groups, we're doing the same thing. So here, let me just go into this area here, and let's select this vertex. Let me go back to my history, and I'm going to switch the angle to this guy. So let me just set this to 180. This is just going to smooth completely across this vertex. And so if we take a look, I've got this green line here. Let me just focus this. So I have this green line here. This is actually my vertex normal, and you can see that we have one vertex normal here. And if we were to set this angle to 0, so it means we're going to create a hard edge or a split right here. So here I'll set this to 0. You can see that the vertex normal gets split into 2 in order to create this split here in the actual smoothing group. Now Maya sees this, as you can see my verts are selected as 1. Maya still sees this as one vertex. However, when the GPU renders this, it's going to actually have to take this vertex because of this split here in the smoothing group, and it's going to have to split that vertex into 2. So just by adding in this smoothing group, we're actually going to be splitting the vertex as well. So just as with smoothing splits, UV splits will do this as well. Let's look over here into my UV editor. And so here, I'm just going to have my edge selected yet again, and you can see that I have this discontinuous edge here in my UV. So again, wherever the GPU sees this UV split, it's going to have to split the vertices at this discontinuous UV edge. Now we can use this to our advantage because in this case I have this UV split, so we know that this vertex that I have selected here, which is showing as 1 in Maya, however when it renders on the GPU it's going to be split into 2, so I know it's already going to be split into 2, so it's not going to cost me anything extra to place a smoothing split here as well. So now let's look at an example where I'm using smoothing splits to correct for some of these shading errors that I have here on my mesh. So I'm going to turn off this layer and I'm going to come over to this splits layer here. And so here I have the same mesh. You can see I have the same UV layout. It's just that I've added some smoothing splits. Now I have my edge mode selected here, and we can see the edges that I have hardened and thus created these smoothing groups. Some of them fall along UV splits, and some of them, like in this case here, do not. Some of them fall on a continuous UV. So let's take this object here and let's just bake this into Substance Painter. So I'm going to go to File, Export Selection, and in this case we're going to leave our tangents and binormals enabled, smoothing groups, and triangulate, and let's just save this guy here as parts_splits. And now let's jump over to Substance Painter and bake this. So here in Painter I have baked the normal map, and you can see that we're actually having some problems here. So right along the edges we've got this dark line, this artifact that's rendering. Now if we take a look at the normal map itself, here you can see that, well, it looks a bit cleaner. The gradients are not nearly as extreme as the first normal map that we baked. However, we have this edge artifact, and this has to do with the hard edges that we placed on the model. Let's jump back over to Maya and take a look at what's actually causing this. So here in Maya, I have this edge selected right where we're having this artifact. And notice that this edge is continuous here in the UV shell. Now the object is floating point, so we have basically this kind of infinite level of precision. However, the normal map that's baked, it's rasterized, so its precision is really based on the amount of pixels. Now when we take a look at this continuous edge, we can see that to the left, we have this pink value, and directly to the right, we have this dark blue value. So when this texture is filtered, these values are bleeding across this continuous edge. And thus, it's creating this edge artifact that we have. Now, this brings us to a very important rule, and that is wherever we have a smoothing split, we must also have a UV split with padding, which is definitely not the case here. Again, let's take a look at this entire edge. So I'll just double click to select this entire edge, and you can see this entire edge is continuous here in the UV shell. So here I'll show an example of how we can fix that. So let me just go over to my layers here. Let me just enable a new object. And so here is my splits with padding. Let me just disable the texture, and let's take a look at the UVs. And let me go into edge mode, and I'm actually going to go to my select. I'm going to use some constraints here, and I'm going to make sure that my smoothing constraint is set to hard. And now we'll just make a selection. So we've only selected all of the hard edges. So this is everywhere we have a smoothing group. And notice that the corresponding UVs have been split right at the areas where we have a UV split, a smoothing split. So here we can just demonstrate this with just this edge here. So notice here we have this edge, there's a smoothing split. Here in my UVs, I've introduced a UV split as well. However, I've also introduced some padding between these two. So basically I've taken this UV shell and just separated it so that we have this area of padding. So now let's take this object and let's export this back to Painter and take a look at the results. And so here we are back in Painter, and you can see that by adding the padding to the UV splits where we have smoothing splits, we get rid of the edge artifacts, and once again we have a nice clean result here to our normal map bake. Let's take a look at the map itself, and here you can see that it as well looks very clean, and we've minimized the gradients with our smoothing groups. Here again we can compare that to the original that we had. The gradients, again, much less extreme here in our normal map, which means that it could compress a little bit better. Now let's jump over to Unity and take a look at the result. So here we are in Unity. Here is our object that we just baked. This has the smoothing splits, and here is the object that we used previously. This has this single smoothing group. Now you can see that the result is identical between the two bakes. However, this single smoothing group is going to be just a bit more optimized, and I can demonstrate that by taking a look at the game view here in Unity. So let's just take our splits with padding object, let's just disable that, and then here in our game view, notice that the triangle count is 464 and the vertex count is 324. So here, let's disable this guy and now take a look at the padding. So we'll go to padding, we'll enable this guy. Notice the triangle count is the same, however, our vertex count has jumped up to 395. And that's due to the smoothing and UV splits that this object contains. So that's going to cover the process for baking good normal maps. We've covered the workflow for both Unreal Engine as well as Unity. The big takeaway from this is that in order to get the best results, you're going to need to, number one, have your object fit as closely to the high res as possible. Number two, make sure that you're working with the correct tangent basis when you bake the normal map. You need to create a synced workflow between the tangents used to compute the normal map as well as the tangent basis used to view the normal map.